Good morning, students. Today we are going to learn the subject R.C.C. The full form is Reinforced Cement Concrete. It is the most useful subject in the field of civil engineering. It has its uses from basic to advanced level. The full form denotes the reinforced cement concrete. Reinforced are the rebars, while cement concrete, in concrete it's a mixture of cement, sand, aggregates, coarse aggregates, fine aggregates, and water. So, in today's class, we'll going to learn detail about concrete technology. In today, we will learn detail about the properties of concrete, classification of cements, specification of Portland cement, specification of aggregates, measurement of materials, admixtures. So, let's start it. So, this is our topic. This is our subject topic. We will cover this in almost 6 to 7 lectures. So, let's start it. So, our today's first chapter is concrete technology. In this concrete technology, as I said before, what we are going to learn. So, let's start with the properties of concrete. It is the construction material which is obtained by hardening of mixture of cement, sand, gravel, and water in a predetermined proportions. This mixture is used by pouring it into suitable molds and allowed to harden and then cured. So let's move forward to the characteristics of concrete. In the characteristics of concrete, it has good compressive strength, but it is weak for taking tensile loads. It shows resistance to corrosion and fire. The process of hardening of concrete is time varying and it gains strength with time. The concrete structures are much more economical than steel. Concrete can form hard surface and thus resist the abrasion. Its strength depends upon quality of material and handling conditions. It shows the tendency of sinking initially because of loss of water. It also shrinks as the process of hardening goes on. It can be placed with steel bars to form R.C.C. Let's study about the concrete and its setting time. There are three stages. First is initial setting time. It is usually 30 to 60 minutes. This is the time phase in which mixed proportion attains the pronounced resistance to flow and plasticity is decreased. As per the IS code, it should be more than 30 minutes so that the duration this phase concrete can be mixed, transported, and used at required place. So, the second setting time is the final setting time of concrete. Usually, it takes about 5 to 6 hours. This is the second time phase during which concrete remains relatively soft solid with no surface hardness. In this time concrete starts gaining the strength. As per IS codes, it should not be more than 10 hours. And the third stage is progressive hardening and increase in strength. This is the third time phase during which concrete almost attains most of its strength during initial stage. This process is quite rapid. It is generally 1 month after mixing. A small quantity of gypsum is added in the cement. The initial setting time is controlled by the quantity of gypsum added. More the quantity of gypsum, more will be the initial setting time. So, let's move forward to the classification of cements. The cements are classified into 5: Portland cement, high alumina cement, and super sulfated cement, natural cement, and masonry cement. So we're going to learn detailed about Portland cement first. The main constituents of Portland cement are lime, also known as calcium oxide, has around 60 to 67%. The other constituents of Portland cement are silica, alumina, calcium sulfate, iron oxide, magnesia, sulfur trioxide, and alkalis. And you can see the proportion on the screen. So let's move forward. The aggregaceous material in the form of clay and shale and calcareous materials in the form of limestone chalk are used in around 1:2 ratio. When raw materials containing above constituents undergo burning and fusion, the chemical reaction takes place and following compounds are formed called as Borghese compound. So these are the 4 Borghese compound. First is tricalcium silicate C3S, dicalcium silicate C2S, tricalcium aluminate C3A, tetracalcium alumino ferrite C4AF. I'm going to tell a short about these. C3S and C2S contribute to the most of eventual strength. However, initial setting is due to C3S. C3S quickly hydrates and contributes initial strength. Contribution of C2S is after 7 days of mixing and extends up to 1 year. The strength of first 24 hours is imparted by C3S. All the 4 compounds lose heat when mixed with water. C2S generate minimum heat whereas C3A generate maximum. Therefore, C3A is responsible for undesirable properties of concrete cement. Having lower C3A content will have higher ultimate strength, less generation of heat and less cracking. So now we'll move forward to the types of Portland cement. There are generally 8 types of Portland cement. We'll discuss each type in brief. The first is ordinary Portland cement. It is the manufactured generally in large quantities than others. It is generally suitable in concrete construction where it is no exposure to sulfates in soil or groundwater. This is the most important part of this cement. And the second type is rapid hardening Portland cement. It is also known as high early strength cement. It is ground finer, contains lesser C2S and C3S as compared to ordinary Portland cement. Strength developed in 3 days in rapid hardening Portland cement is nearly equal to the strength developed in 7 days in ordinary Portland cement. But shuttering may be removed earlier, thus saving time and expenses. The third is extra rapid hardening cement. It is obtained by inner grinding of calcium chloride. With rapid hardening cement, it imparts quick setting properties also. The fourth is low heat Portland cement. This is used where the rate at which heat can be lodged at surface is lower than the rate which heat is being generally initiated. The examples where it is used is abutments in bridges, retaining walls, and dams, etc. The fifth cement is Portland blast furnace cement. The proportions of slag vary from 25% to 65% by the weight of cement. In Portland blast furnace cement, it is manufactured by intergrinding of Portland cement clinker in blast furnace slag. It has comparatively low heat of hydration and can be used in the replacement of ordinary Portland cement. Gypsum is added to regulate the setting time of cement. The next cement is Portland pozzolana cement. It is manufactured in the inner grinding of Portland cement clinker and pozzolana, burnt clay, shale or fly ash. It's the blending instead of inner grinding. 10 to 25% of pozzolana can be added or used in practical means. This cement has more resistance to chemical and seawater attack. It also has low heat of evaluation. The next is sulfate resistant cement. In this cement, the quantity of C3A is strictly limited. And they are normally ground finer than OPC. Resistance can form through carbonation by action of atmospheric carbon dioxide. This cement should be allowed to harden in the air for as long as possible. The next is white and colored Portland cement. The color is obtained by adding pigments in ordinary Portland cement or white cement. Pigment should be permanent or chemically inert. The percentage of iron oxide is limited to 1%. Sodium aluminate fluoride is added to act the flux in absence of ferrous oxide. So, we're going to learn about the next 4 types. The first is Portland cement and the next is high alumina cement. In high alumina cement, the raw materials is manufactured and are extremely high alumina content. It has dark color, high early strength, even than rapid hardening cement, high heat of hydration, and more resistance to chemical attack. Manufacture is more expensive than ordinary Portland cement. The next part is super sulfated cement. According to IS 1990, it is manufactured from well granulated blast furnace slag, about 80 to 85%, calcium sulfate about 10 to 15%, and Portland cement about 1 to 2%. It is the ground finer than OPC. It has strength resistance to chemical attack. Concrete derived from the cement expands if cured in water and shrinks if cured in air. So the next cement is natural cement. These are manufactured from naturally occurring cement rocks with compositions similar to mix of aggregates and calcareous materials. Natural cement rocks are burned at comparatively lower temperature. The properties of these cement depends upon the composition of cement rock. Masonry cement is the last type of cement. This is manufactured from grinding the Portland cement clinker, limestone, gypsum, and air entraining agent. These are ground finer than the high early strength Portland cement. This is used for mortar in brick masonry. Limestone and air entraining agents impact plasticity and workability shrinkage in fairly low. So next we are going to learn the specifications of Portland cement. Specifications mainly are the chemical compositions. In chemical composition, it is depend upon the ratio of the percentage of lime that should not be greater than 1.02 but not less than 0.66. It is calculated from the formula. And the second is the ratio of percentage of alumina to that of ferrous oxide. It should not be less than 0.66. The weight of absolute residue should not be more than 2%. Weight of magnesia not be more than 6%, and the total sulfuric anhydride should not be more than 2.7%, and total loss of ignition should not be more than 4%. This is the most important in chemical composition. The second is fineness. The fineness, this is done by grinding. If the cement has low heat, there are three types of cement used in fineness. Is the first is low heat. Then the specific surface should not be more than 3200. In rapid hardening cement, the specific surface should not be more than 3250, and in ordinary cement, the surface specific should not be more than 2250. The third is the soundness. By Lee Chatelier method, according to IS 1968, rapid hardening and low heat Portland cement should have expansion less than 10 mm. The fourth is setting time by Aggregates. The initial setting time of ordinary Portland cement and the rapid hardening and low heat Portland cement should not be around 30 to 60 minutes. Okay, and the final setting time of these cements should be around 60 to 600 minutes. Okay, so next specification of Portland cement is its compressive strength. It is found out with the cube test in IS 1968-4031. The compressive strength at the end of 3 days should be not more than 11.3 Newton per mm square, and that at the end of 7 days should not less than 17.2 Newton per mm square. The sixth point is the heat of hydration. The only for the low heat cement of hydration after 7 days should be not more than 65 calories per gram, and after 28 days should not be more than 75 calories per gram. While finding out the tensile strength, there are certain formulas. We have to take out tensile strength upon 5 plus 2.5 at 3 days should be not lesser than 2, and tensile strength upon 5 plus 2.5 at 7 days should not be lesser than 2.5 Newton per mm square. Now we are going to learn the aggregates. There are two types of aggregates. First is coarse, second is fine. The coarse aggregates, which are retained on 4.75 mm sieve. The maximum size of coarse aggregate is limited to 1/3 of the thickness of concrete section for thin slabs and walls. The fine aggregates are that are passed through 4.75 sieve. Usually natural river sand is used, and angular grain sand produces good concrete because of interlocking. So we are going to learn the specifications of aggregates. There are different specifications like crushing strength. In crushing strength, it should be normally 80 Newton per mm square minimum. It's accepted. And in aggregate crushing value, it has the given formula where 100 W2 by W1. W2 is the weight of surface of dry sample for aggregate passing through 12.5 mm sieve, and W1 is the weight of material passing from 2.36 mm sieve, IS sieve, depending on the specific load. The third is the aggregate impact value. It lies between 30 to 45 for good quality concrete. Higher aggregate impact value is addition of weak aggregates. And the last is fineness modulus. It is also known as the grading of aggregates. It is the index number which is roughly proportional to the average size of the particles in aggregates. Coarse aggregates, higher will be the fineness modulus. It is obtained by adding the percentage of weight of material retained on IS sieve 80 mm, 40 mm, 20 mm, and 10 mm, 4.75 mm, 2.36 mm, 1.18 mm, 600 micron, 300 micron, and 150 micron. These are the total 10 sieves. And the last part is the water. Water is a lubricant for aggregates, and chemically acts with cement, also used in curing potable water, is satisfactory for mixing and curing purpose. Tannic acid or iron should be present in water. pH value should not be more than 6. In organic solids, the water should be 200 milligram per liter. In organic solids is 300, sulfates is 400, chlorides is 200 mg per liter for concrete not containing embedded steel, and 500 for R.C.C work. Suspended matter, it has permissible limits for solid for 2000 mg per liter according to IS 456-2000. When suitability of water is doubled regarding the development of strength, then compressive strength and initial strength time tests are done. So we're going to learn how the materials are measured. Firstly, the cement, preferably measured in the terms of weight but not in the terms of volume. Each cement bag contains 50 kg under normal conditions, and the volume of cement bag is nearly equal to 34.5 liters. The second is fine aggregates. The fine aggregates are measured in weight for accuracy works and by volume for ordinary works, and the volume is increased due to water absorption by sand, called as buckling of sand. Sand particles are pulled apart from the surface tensions caused by water. Increased in the volume depends on gradation but may be taken to the maximum at the moisture content of about 4% of dry sands. Buckling increases with the fineness and may be around 25% of volume. We can calculate it by percentage of buckling is equal to increase in volume and original volume. Okay, so next part is the coarse aggregate. There is no problem of buckling. It is measured in volume or weight, either for accuracy or large scale work. This should be measured by weight. And water, finally water, we know that it's measured in volumes, the liters of water. The next topic is water cement ratio. More water increases the workability but decreases the strength, whereas water's content increases strength. Moreover, use of excessive amount of water also increases shrinkage and decrease density and durability. So, what is durability of concrete? It is the property by virtue of which concrete is able to resist its disintegration and decay. Reasons behind disintegration and decay of concrete may be use of unsound cement, less durable aggregates, entry of harmful salts and gases through pores of cracks, freezing and thawing of water sucked through cracks, and expansion of contraction due to temperature variation. The next important topic in our syllabus is admixtures. For the quality improvement purpose, some ingredients are added in concrete which results in changing different properties in its fresh hardening stages. The properties improved may be strength, hardness, workability, water resistance, power, etc. Commonly used admixtures are calcium chloride, alum, coal ash, common salt, bitumen, iron oxide, lime, mineral oil, organic oils, volcanic ashes, and many more. There are different types of admixtures used. Some of them are accelerators, air entraining admixtures, super plasticizers, retarders. They have different advantages. Some of the advantages are adjusting final setting time, gain higher early and ultimate strength, higher slump and self-training concrete, self-traveling concrete, increasing durability and workability, lesser water cement ratio, reducing quantity of cement, reducing permeability of concrete. So, our next most important is proportioning of concrete. The process of selection of the proportion of cement, sand, coarse aggregate and water as learned above, so that the concrete of desired quality can be obtained. The proportion should be such that resulting concrete have following properties. The one is the fresh concrete should have enough workability so that it can be placed in form work economically. The second is the cost of materials and labors needed to form concrete should be minimum. The concrete should possess maximum density so that it will be watertight and stronger. The last but not the least topic of today is workability of concrete. Workability is the ease with which concrete can be mixed, handled, transported, placed in position and compacted. As per IS 1959, workability of concrete is the property which determines the amount of internal work necessary to produce full compaction. Workable concrete should not show any bleeding or segregation. To determine the workability of concrete, following tests have been developed. The one is slump cone test, compacting factor test, VB test, and vibro workability test. We'll learn in detail about these tests in further lecture. Before that, we'll going to learn the vertical settlement is measured in slum in millimeters, and I'm going to tell you the different types of work and its slum results. Like if we test for concrete for road work, the slum results might be 20 to 30 mm. For vibrated concretes, it is 12 to 25 mm. For mass concrete, it is 25 to 50 mm. And for column retaining walls in thin vertical sections, it may go for 75 to 100 mm also. The greatest factor affecting workability of concrete is the mixed amount of water. As water increases, workability also increases with strength, but the strength decreases. Other factors are maximum size of particles, ratio of coarse and fine aggregates, particle interlocking, particle interface, and admixtures. So today we are going to end this lecture over here, and in next lecture we are going to learn the basic mixed design of concretes. We're going to learn in detail. If you like my lecture, if you like this subject, if you want to learn more about R.C.C, please subscribe my channel, tap the like button, and share it to your friends such that they would also gather the informations I'm discussing here. Thank you so much.